Right? Remember that you have to submit both as the file, the Word file and the complete package JSON file. Now I want to review about. I see something wrong with your package JSON here, so I want to review a little bit about how we configure the IP address or in the network here. So that remember that I mentioned on the class as the router. When you have the router is a layer 3 device. Right? The router, you have the two functions of the router. The first one is interconnect the network together. If you have the two different networks, you interconnect the network together. And the second one is that the second function of the router is always tell you which is the best way to reach a destination. Okay. And one more thing about when you work with the router, remember that each interface of the router is a one network. It connects to one network. So think about this one. When you look at the topology here, you have the one router here. You have the one router for this one. So what do you think? How many networks you have for this one? How many networks you have for this topology? Any idea? How many networks you have? Hello? How many networks?
What was the question?
If you look in the topology here, how many networks you have? What do you think? How many networks do we have here?
Seven.
Come ahead. Go ahead. What is it?
The 172.168.1.1 is a network, and then 192.168.1 is a network.
Okay, so what do you think? How many networks you have?
I think there's
two.
Three. I see 172, 192, and one. Oh wait, never mind. There's two. I think.
Yeah, there's two different networks, I think.
Okay, so here, right? That I mentioned it again that each interface of the router is one network because the router is the one who interconnect network together, right? So we see you only have one router here, right? You have one router for the network, and you have the two interface here, this one and this one. So definitely this one, you only have the two network, right? So we can think about this one here. Here is one network, right? You have here is one network, and you have any other one here. Everything here is one network. So remember, each interface of the router is one network. That's all. You have to remember that each interface of the router is another one network here. Okay, so that's why you see the one network here. You see the one network here. You have everything about 192.168.1 or something here, right? And this one here, you have 172.31. And .0.0 here is a network. For this one, you have the two networks. Okay, so one thing you have to remember when you configure the IP address for the computer on the network, you have to know that. You see, every computer on this one, they are on the same network, right? And one more thing you see, whenever you want to go out, right? So we think about this one. If this computer here want to communicate with the computer here, it's not on the same network, right? So whenever you communicate to the remote network, they call it the remote network. That means not on the same network. So whenever you want to communicate with the remote network, you only have one way to go out. That is the default gateway. Right? You see, from this one also, if you want to ping this computer here, you also have to go to the default gateway. And this one also, if you want, you also have to go to the default gateway. That is the reason that every computer on the same network, you have to configure with the same default gateway. Right, same default gateway here. You have to configure the same default gateway. And the default gateway, it is the IP address of the interface of the router. So we see, if I configure this one here, 192 here, 168.1.1, I have to go to every single computer here. And I have to configure the default gateway, it is 192.168.1.1. That is the IP address to tell the computer that whenever you want to go out, you have to send it to the default gateway. All right? So if you look on the topology, if you look into my work here, you see I can check it by every single computer here. I can go to this computer here and I can check with the command here, IP config. So see, I have my IP address here, the subnet mark here, and the default gateway here. You see, the default gateway, it is the one I got it from this one. I got it from the interface here. Sorry. IP address here. Okay, so see, for every computer, I have to convert it to the same default gateway here. I can check it here also. I see, I have everything with the same, but remember that default gateway is always the IP address of the interface router. Now the thing is that here, that remember that you only need the default gateway whenever you want to go out. I see, if you want to go out here to this computer PC file here, you have to go to the default gateway. This guy also. But the thing is that when you communicate together in the same network, I think about when you communicate together on the same network here. Now think about this one here. That remember that every computer here on the same network. Every computer here on the same network. So now, if you want to ping from the PC .10 here to the 20, they are on the same network. So see, when they are on the same network here, they can directly communicate together. You don't need to go out to the default gateway. So see, in that one here, in that one you can see that if I delete my default gateway, it doesn't matter here. If I delete my default gateway, it's the PC one here. I delete this one here. And even that after I delete it, I still able to ping to the .1030 here. I can see I ping it here. 192.168.1.20. So see, the reason that I'm able to ping it because you are now on the same network. You don't need to involve the default gateway on this one. You don't need to involve the default gateway on this one here. From the PC 10.10 here to 20, you are on the same network. You don't have to go to the default gateway. So that's why even that after I delete my default gateway, I'm still able to communicate here. But the thing that if I delete it, I am not able to ping to this guy anymore. I am not able to ping to this guy anymore because not on the same network here. So you can see, if I ping here, 172.31 here, .1.10 here. I have no way to communicate with this one because it's sent to the default gateway. But in my PC, I deleted the default gateway information. That's why the computer have no way to send to the default network here. And for this one, I have the default gateway here, right? So see if I am able to ping it or not. I see. I ping it here. Sorry, ping this one 172 here. 31, 1.10. See, you see, for this one I'm able to ping it because I configure the default gateway, right? But this guy here, I'm not able to ping it. This guy here, I'm not able to ping it because I delete the default gateway. So now, if I want to ping it again, I have to put information of the default gateway. And remember that the information of default gateway is the IP address of the interface router here. So I put it here, 192.168.1.1 here. So now I do it again. Let's see if I am able to ping it again. It worked, right? So that is the purpose of default gateway. So remember that you always need to incorporate the default gateway whenever you want to ping to the remote network here. Make sense? Hello?
Yeah, that makes sense to me.
Okay, now I come back to the one of the homework of you guys here. I see that something wrong with this one. Or this one. For this one, you see, you configure the IP address here 192.168.1.0 and the subnet mark here, correct? And 172 here, 168.1.100 here, and the subnet mark here is correct as required. And the default gateway also, sorry, the IP address of the interface of the router here, 192.168.0.1, and the subnet mark here, and this one, everything correct. But the thing is that you are not able to bring them together, right? You are not able to bring them together. And that's the reason here. You see, if I look on this one here, I see if I configure IP configuration. What is the reason? If you look at the information here, what is the reason why you are not able to bring to the other computer here? What do you think? Any idea? Any idea? Why you are not able to bring?
I don't know. I had the same problem.
Now, if you look on the IP address here, 192.168.0.100, correct? The subnet mark here, 255.255.255.0, correct? The default gateway correct or not?
No.
Why?
That's not correct.
Why? Why not correct? Why is not correct? Why not correct?
It's the same as the IPv4 address, which seems like it should be something different, like whatever the router's address is.
I see the default gateway, and let me mention it again. Where you got the information of default gateway? Where you got it? Remember, for every computer on the network, you have to configure the default gateway, and the default gateway is the IP address of the interface router, right? So see, you configure this one here. You configure this one 192.168.0.1. So you have to configure the default gateway here. It's 192.168.0.1, not 100. 100 is your computer IP address. You got my point? Oh, come on. You got it or not?
Yeah, I understand.
Now see, again, you can think about this one here. For this topology, again, you have the two interface router, right? So for this one here, you have the two network. You have one network here, and you have another network here, right? And remember, every computer on the one network here, when you configure the default gateway is always the IP address of the interface of the router connected to it. Right? Think about this one here. If you have another computer for this one here, and you configure it to 192.168.0.200 here, right? When you configure the IP address here, 192.168.0.200. And if you want to communicate with this IP here, you have to configure the default gateway is 192.168.0.1. You got it from this one. Right? And so this one also, you have to configure the default gateway is 192 here, 168 here, .0.1. You got it or not? The same with this one also. When the computer on this side here, when you configure the default gateway, you have to get this IP address from interface router here. It is 172.16.0.1. So when you configure the default gateway, you have to put the information here, 172.16.0.1 here. So only after that you are able to bring them together. Otherwise, you have no way to bring them together. All right. So see, now if you look on the topology here, if I have one more computer to connect to the topology here. See, if I have one more computer here, let me do one more computer for this one. I put it here. I connect it to the switch. And I configure this IP address here. 192.168.0.200 here. The subnet mark is here. But remember that the default gateway, you have to get it from interface router here. You have to put information 192.168.0.1. Okay. Now, Even for this one, I remember that I don't need information here. I don't need information here. So what happened here? I am able to bring them together, right? I am able to bring them together from the two PC on the same network. Okay, so now see, if I am able to bring to the 192.168.0.100. You see, on the same network, right? I just go to the street, I go to the definition here. It's okay. But I am not able to bring this guy here. I have no way to bring this guy. I see, I bring here 172.16.0.100. No way. No way, because it is a remote network. And remember that in the case of remote network, the computer has to deliver to the default gateway here. But you see, in the information, you have not configured the default gateway yet, or if you configure it incorrectly, you have no way to bring to the remote network here, right? So for that reason, you have to correct it to the correct information here, 168.0.1. That is information you got it from interface here. All right, so now see what if you are able to bring it or not. All right. Still not able to bring it. The reason is that you also convert this one incorrect here. All right, see, you see, if you look on this one here, you convert this not 100 not correct. You have to got it from the interface here. And that's why you have to change it to number 1 here. So now what happened here? You see what happened. See, right? After you convert the default gateway correctly, you are able to bring it. Right? So that's why for this one you also have to change it to number 1 here. This one you have to change it to the number 1 here already, right? So now see, you are able to bring it together. Now, work perfectly, right? So you got the idea of that or not? Yeah. Remember that for every computer on the same network, when you configure for the IP address, everyone on the same network, you have the same default gateway. That definitely you have the same default gateway. And the default gateway information, you have to got it from interface of the router where you connect it. Huh?
Got it. That makes sense.
Yes. Any other question?
I'm good here.
Okay.
Yeah, I don't have any questions.
Okay, so if you don't have any question, let me go with the module 7 here. Okay, so on this module, you're able to explain the type abstraction of the design physical network architecture, and explain virtualization technology on the network, summarize the cloud characteristic model and connectivity option, and identify the method to increase the network availability here. So far we work with the switch. Remember, the switch is a layer 2 device and interconnect the device on the same network together. Remember, the switch is on the same network, and the router is an interconnect network together, right? And for the switch, you have the 2 types of switch. The first one, you have the unmanaged switch. It is that kind user provide plug and play capability with the minimum configuration. You have no IP address to assign. So for the switch here is that very simple switch, and you have no way to remote access to the switch here because you have no IP address, right? And normally you are not able to do any configuration with this one. And the second one, you have the managed switch. It can be configured. It can be the common line interface or the web-based management geographical user interface here. And the switch basically they are layer 2 device. It only understand about the MAC address. You have no idea about the IP address, basically, right? But nowadays they can have the switch layer 3 and the switch layer 4 also. So the switch layer 3. So when we go with the layer 3, it's able to work with the layer 3 data and works like a router because the router works with the layer 3. And you also have the layer 4 switch also. It capable of the interpreting the layer 4 data. Okay. Now when works a switch, normally you work with the redundancy here. Redundancy is that allows the data option to travel through more than one switch. You can avoid problem of single of a failure here. So think about this one. If you look on topology here, so think about if you go to the computer, you go to the switch here, and from the switch, from the switch here, you go to the router here, you go to the router and you go to the internet here. So see, you only have one way to go out to the internet, right? That is the problem of single point of failure here. What happened if you are going down here, or what happened if you are going down here, right? So in that case, in order to increase the availability and of the network, you can use the redundancy here. Redundancy, that means you have more than switch, you have more than router, right? So we see you can have the one more way to go to the router here. So with this one link down, you still have one other way to go down, right? So that is the definition of the redundancy. Redundancy allows the data option to travel to more than one switch toward its destination and make your network less vulnerable to the hardware malfunction here. But the thing is that when you work with the redundancy, you have problem of having multiple paths through the network, and it might have problem of the loop here, traffic loop here. I think about, let me see this one here, right? So think about this one here. All right. So if you look on the topology here, so in order to communicate from the PC here to the PC here, right? So you see, you work everything with the redundancy here. You have more than one path, right? So we can go on this way and you go to the destination, or you can go this way and go to the destination here. But you have problem of the looping here. So what happened here? You see, what happened if you have the routing looping, right? You send it to switch send it to switch here, switch send it to this one, and switch one is this one here. You have a looping problem here. Right? In the case of the loop, and that remember that in the case when you work with the broadcast message here, broadcast. Broadcast message, that means the message you send it to everyone on the same network. I still think about this one. If this guy here want to send a broadcast message, I send it to switch. So basically the switch, when you receive the broadcast message, he send it to everyone. He send it to every interface except from incoming here, right? So now see, if this guy here receives the broadcast message from the incoming here, right? So switch forward it to everyone, right? Again, when the switch here receives the broadcast message, he forward to everyone, Again, this one also receive it, he forward it to everyone and forward it to everyone here. Okay, so see, if you have a broadcast message and if you have a looping problem here, you see the broadcast message going forever, looping forever here, looping forever. So when you have the looping message forever, you have huge problem with the network here. The first one, everyone here take time to process it. I see, whenever you receive message, you have to read at the header and you look at the MAC address table here, know where to forward. The first one is processing time here. Processing, slow down process. The second one here, you have huge problem with the bandwidth. You see, when the message going out forever, it consumes a lot of the bandwidth for this one here. Right? So that is the case when you work with the redundancy, you have a potential problem with the multipath by the traffic loop here. So in order to mitigate this problem here, they use a technique. It is a FTP here. FTP is a spanning tree protocol. The purpose is that it prevents the traffic loop. It prevents the traffic loop here. So it also calls the switching loop here by it calculating the path that avoid the potential loop by blocking here, artificially blocking the links that would complete the loop here. Okay, and FTP here, it can also adapt to the chain in the network. Remember, it adapts. So any chain in the topology, it can recalculation and it adapts to the chain of the network here. And normally the FTP here, it's only choose the most efficient path, and the core is the least cost path here. Now, if we look on this one here, again, If you look on this one here, okay. So you see, if you don't use a spanning tree protocol, you have the loop here, right? You see, you have the loop here. You have the loop here, right? So now, if you work a spanning tree, here, for average tree, they do the calculation and they determine they have to block somehow they have to block one link here in order to prevent for the loop, right? So think about this one. After a lot of exchange information here, this guy here decides that this one you have to block it out. I'll see. So from this one here, when you send it to the computer here, now you only have one way to go, right? So you can prevent problem of the looping here. But remember, the FTP here, it can adapt to any change in the topology, right? So what happened here? Something, if you're going down, the link here going down. So FTP is smart enough. So FTP is smart enough. It do everything recalculation again, and it can bring this up here. So it can bring the link here up. So now you can go from this way and go on this way, go to the destination here. So you see, by using the redundancy, you avoid problem of single point of failure. And using this FTP here, you prevent problem of looping here in the layer 2E. It makes sense? Okay. So remember, this one it is temporary, but anything change, any change in the network. So if the link here go down, it will. Sorry, this one here go down, is still the same. But this one here, if this link here go down, it will automatically bring this link here go up, and it's still able to go to the destination. Okay, so in the case FTP is a spanning tree protocol. Information is transmitted between the street via the BPDU here. They call it the BPDU. BPDU it is bridge protocol data unit. So they exchange information together. They do a lot of the calculation as they can determine which is the best link. You have to block it to prevent the problem of looping here. And remember, it can adapt to any change in the topology. If you have some link going down, it will bring up the blocking link here. Okay, so we have the sum of the security precaution. It must be configured on the FTP enable interface includes. The first one is a BPDU guard here. The second one you have a BTU filter, and the third one you have the root guard here. So let me show you how we work with what is a BPDU guard and what is a BPDU filter and what is the root guard here. See, I have the simulation. Okay, this one. Okay, so now if you look on the topology here. Okay, so this one also. If you look at the topology here, you have the loop, right? You have the loop here. See, you in the case here, if you want to bring from this one to this one here, right? So you see, you have two ways to go. This one, or you go on this one here, right? You go on this one here. So now they work with the FTP. FTP here, spanning tree protocol. So FTP, spanning tree protocol, right? So after a lot of the calculation, after a lot of exchange information here, all the street here, they determine that they have to block this one, right? In order to prevent the loop here. So now we see, if you want to ping from this PC here, you have to go along the way from this one, route to the switch here, and go to the destination here. You cannot go on this way, right? Or go on this way here. So here, what happened here? See, right now, this one, they call it the alternative link. Right? But what happened here? If I block this link, here, it will automatically bring this link up here. Now, see what happened here. All right? what happened if so see right now, you can see it right now. You work with the simulation here. You want to bring from this one to this one. So see, go simulation. Bring it here. See, you go to the switch here, and it cannot go on this way because it's in here blocked. So see, it forward to this one, and now it forward to this one, and now it forward to the attention here. You see, you cannot go on this way. Have no way to this way because by Spanish G know that you have to block here. So now what happened here? Let's see what happened here if I delete or I bring it down. So this in here. So I turn it off. So now see what happened here if I turn it off. Let me go to the other tab. So after this one link going down, right? See now this one automatically going up here. You see it have green here instead of the yellow before, right? Ever yellow before. You see. So now what happened here? If I work with simulation again, I send it to the switch. Send it to this one, and this one send it to the attention here. So that is the benefit of Spanish protocol here. That is the benefit of Spanish protocol. And you see, whenever you have any change in the topology, it automatically adapts it to the new topology, right? So you see, when it detects that the link here going down, it will automatically bring up this link here. Right? So see, you avoid problem of the single point of failure here. It makes sense?
Yeah, that makes sense.
Okay. Okay, so see, when I bring it up again, this one come back to the blocking mode here. Okay, and in the case Spanish protocol, in order to know which port you have to block it, you have a long process of each information. Right? You have the process of elect the root bridge, and you have the process of elect the root port, and after that you have the process of the elect the alternative port here or the designated port here. We talk about it later when I explain it here. Now you have something about the BPDU guard and the BPDU filter here. So let me show you what is a BPDU guard here. Let me see if I have it here or not. So basically, when the switch work with the Spanish protocol, when the switch work with the Spanish protocol, it is by default. It is by default activated in the switch. So think about this one here. So we think about when we work with by the default, right? So think about if you have one of the switch, you connect to the port of the switch here. But automatically they involve into the Spanish protocol here, and it change information together. Is here. So that is one problem with the Spanish protocol here. That's one problem with the Spanish protocol, because you think that if you think about you have the bad guy here. You are the bad guy, right? You have some bad guys here, and when he connect it to the switch, by automatically he able to exchange every information about the Spanish protocol, and he know what. He can know what's really going on with the networking. So sometimes that you don't want to activate Spanish information here. Sorry, you don't want to activate Spanish protocol in every interface of the switch here, in the order of the security here, right? You want to enhance security. Right? So in the case of security here, you don't want every switch exchange information by the Spanish protocol. They call it the BPDU here, BPDU. So in order to determine which one is you have to block it, you have to a lot of process of exchange BPDU together here. So in the case here, you don't want this switch here. Sorry, you don't want this port here involved in the information of exchange BPDU here. You have to work with the BPDU guard here. BPDU guard. BPDU guard. So what is that? So if you have the switch connect to the interface here, and this one try to send out the BPDU message here into the switch will block the interface here, and you have no way to connect to the switch anymore. That is a process of security here. You see, if you don't want everyone connect another switch to the switch here, so he able to capture everything here, you just block it on this one. If this one send out the BPDU message, you block the port here. So now, if you configure it on the switch, you can see. By the default, I don't configure anything, so I have another switch here, and I can connect it. I can connect it to the switch for this one. I have no problem with this one. I have no problem here, and it's going up, and now I can see I have information about the exchange information about BPDU here. So from the point of view, this one, when you connect the switch together, you set up the channeling, and when you have the channeling, that means you can see any traffic going on with the network. It's not good for the security purpose here, right? So in that one here, see, I have the switch here connect to the F0/5, right? This one here connect to the F0/5. Yeah, F0/5, right? So now what happened here? I go to the switch. I go to the switch. I go to the switch. I go to the interface F0/5 here. Spanish key. Okay, Spanish key. I have BPDU guard here. Enable. Yeah, you see, after I set the Spanish key protocol enable, right? You see, this guy here, if you want to enable in the Spanish key, he have to send out the BPDU message. But I set the BPDU guard here in the F0/5, right? So whenever he receive to the BPDU guard, whenever he receive the BPDU message, he will disable the port here. I see. Right now we have no way to communicate and involve in the Spanish key, right? That is the purpose of the Spanish BPDU guard here. But what happened here? If I connect it to the PC, right? I have connected to the PC. I connect to the same port. You see, I connect it to the same port here. I connect to the same port F0/5. Oh, so this one you have to bring it up first. Sorry. Okay. So now you see what happened here. If I do it again, right? If I do it again here, what happened here? Oh, sorry. What happened here? If I do it again for the BPDU guard in the interface here. F0/5. I put the Spanish key, BPDU enable here. So now see, right? before when I configure the BPDU got enable and whenever I connect it to the switch, the port will going down, right? The reason that the port going down because when it connect to the switch send out the BPDU message. But the PC never involved in any exchange information of the BPDU. So when you connect to the BPDU here to the same port, you have no problem with that one. So see, by using the BPDU guard, you make sure that you prevent any switch connect to the port here. But any device, PC or printer or the server, you have no problem here. Make sense? Hello?
Yeah, it does.
The thing is that here, the switch, whenever connect the switch exchange information about the Spanish protocol and the message they exchange together, they call it the BPDU here. Right? And you want to prevent this one connect to the switch, you have to put the BPDU guard here. Right? So whenever we connect to the switch, it automatically shut down, prevent you from the connect to the switch. Right? But when you connect to the PC here, PC have no information about the BPDU message. That's why the link is still going up here. You have no problem. So by configure the BPDU guard here, you are able to make sure that no another switch here able to connect to the interface switch. Okay. Okay, so you have the sum of the BPDU guard that it prevent it from the connect to the other switch. You have the BPDU filter here, in the case BPDU filter, that whenever you connect to the PC, the switch do not send out the BPDU message. But whenever you connect to the switch send it out here. The root guard is that the thing is that when you come back to the Spanish key here, when you come back to the Spanish key here, so in order to know which link you block it, you have a whole process, you have a long process of the elect the root bridge here. So you can think about this one here. You can think about this one is a root bridge. This one's a root bridge here. This one root bridge. And the process of elect the root bridge, you have the long process here. The first thing is that you have the priority, you set the priority here. And by the default, every switch, they have the same priority. So when they have the same priority, they come up with the first one is the priority here. All right, priority. That's the first thing. All right, so we can check here. You can check on the you can check by this one here and show spanning tree. One, everyone will be doing that. Right, so we see in the show Spanish tree protocol, you see they have priority here, and by that is the default. So by the default, you have priority 32,768, and the reason it has a 69 because it works with the VLAN number 1. Right, so by the default, if you don't configure for the priority for the switch, by the default here, every switch has the same priority. It is 768 here. And now, when you work with the VLAN number 1, by the default VLAN number 1, that's why you put it 1. So you see, when by the default, if you don't change any priority here, every switch you have the 32,769 here. Right? So see, that is the first switch here. That is the first switch. I can check for the another switch here. I can check for another switch here. I can do the same. So Spanish key and number 1. See, you also have the same priority. You have the same priority. And this one also. This one also you have the same priority. Okay, so see, they have the same priority, right? So now, in order to elect which one is root bridge, you have to process. The first one is check the priority, the check priority here, the check priority. So for any switch, you have the lower priority. You have a high chance of to become the root bridge here. Alright, so see, when everyone have the same priority, the next one you have to check is that you compare about the MAC address here, a MAC address. So which one have the lowest MAC address? It will be the root bridge here. So now we think about this one. You compare together, right? Everyone has the same 0 here. Everyone has the same 0 here. Now we move from the left to the right. Right? Again, this one 0, this one 0, and this one 0. The same, right? Now we move to the right. This one number 0. This one number 0 again. This one number D. This one greater than. Right? Have no way to be bridged. The lower one is the winner. Right? So now you only have this one and this one also. Now we move one. Number 1 and number 1 is the same. Now we move to this one. This one number 9. Right? And this one here, number 6. This one lower. That's why this switch here, if they call it the root, root switch here. The root switch. And when you have the root switch, every port connect the root switch must be active here. It must be interactive here. You see, that's why you have the 2 port here is active port, right? And now, so from the switch here, you see, you have 2 ways to go to the root bridge, right? You see, you can go on this way or go this way here. And this one also, you have go on this way or go this way here. So the first step, it elects the root bridge. You know, this one is the root bridge here. The second one, you have to figure out from every switch here, what is the sorted path? You go to the root bridge. You see, for this one here, this one is sorted here. This one also, this one is sorted here. So for every switch, if you figure out what is the sorted path to go to the root bridge, they call it the root port here. That's why you have the root port for this one. And this one also, you have the root port on this one. The root port also, you have to activate here. You have to activate the port. You have to activate port. So now you see this port here, active, and they are designed because it connects to the root bridge here. This one also active. This one also active because they are the sorted path to come to the root bridge. So now you only have this one left. You see, you can think about this one. If you're standing from here, you can go on this way to go to the root. You can go on this way to go to the root here. I see. This one you have the equal path. So in order to know which is the port, you have to shut it down again. You have to compare on the MAC address here. You have to compare on the MAC address, and which one have the lower. You have the higher priority. I see this one you have lower here. That's why on the link here they come on this one, and they have to shut down this port here. That's the process of the spanning tree here. Anyway, I think this information is out of scope for this class. You don't have to go into too detail for this one. I just want to explain how it works here on spanning tree protocol. And if you want to know more about this one, this class is not for this. And you have to study about the NETI 109, sorry, NETI 119 in the Cisco class here, not this class. Anyway, since I just want to give you the idea of overall idea of the how spanning tree protocol works. Remember that you have the process of elect the root bridge here. That's the process. When you elect the root bridge, every port here they call it the designated port and it's active. That's the first thing. The second thing here, from every switch here, you have elect what is the root port. The root port is the port that you come. You have the sorted path to go to the root bridge here. The root here. Now, so for this one you have to elect which one is designated and which one is alternative here. Alternative port is the one you block it. So see this one the same, right? You have the 2 ways, the same chord. But when you go on the switch here, you have a lower MAC address. That's why you have a higher priority here. So this one designate port and this one alternative here. And of course, when you have alternative, you have to block with the port here. Of course, this one you remember that this one is only for the temporary only. But anything happen during the in the topology that if the link going down, it will bring up this. Any question for this one? Hello?
No questions.
Okay. And you have some of the newer technology to improve replace the ATP here, including the first one, the rapid spanning tree protocol. you have transparent interconnection of loss and link, you have sorted path bridge, and some of the street manufacturer have the design proprietary version of ITP optimized to work with the most efficiency on the equipment here. So remember that in the case of the Spanish tree protocol, you have a long process of exchange information together to know which one is the root bridge, to know which one is the root port, and to know which one you have to block it here. So you have a long process of doing that, and normally it take about 50 seconds. And about 50 seconds here to bring the link up or shut the link down here. Now, let me show you here, right? So think about this one. When you look at the topology here, what happened here? When we look at the topology here, right? So if I want to connect it to the PC here, I connect the PC here. I connect it to this one. Now see, the standard here is not going up instantly. Right? You see, it is amber light here. You see, it is yellow here, and normally it takes about 50 seconds to bring it up here. You can wait for this one here. Right now, it's not up yet. It's not up yet, and you have to wait for the 50 seconds. And the thing that 50 seconds here is that you have to exchange information together to decide if you block this port or bring it up here. That's the process of the exchange BPTU together here. Now see, after the 50 milliseconds, it's going up here. So here's the thing. Here's the thing with this one here. Remember that the BPU message here, the BPU message only involved in the exchange information about the street together. It's not involved in the exchange information to the PC here. I see. To the PC here, PC have no idea for what a BPU here. So normally, to work it fast, they call it a fast here. They call the port fast strategy. So instead of waiting for 50 milliseconds here, sorry, instead of waiting for 50 seconds here, you can activate this one as a port fast. The port fast, that means you don't involve in any information about exchange BPU message here. So whenever you plug in the PC, you can easily access to the network here. You don't have to wait for 50 seconds here. And remember that you configure the port fast, you know for sure you connect to the end device only, not the switch, the switch because you have to exchange BPU here. But whenever you connect to the end device, you can configure with the port fast here. So or they call it the rapid strategy here. Now see what happened here if I think about this one. Now I have another PC here. I connect to the switch again, and for this one, I go to the port F0 slash. Sorry, in the way F0 slash here, and I configure Spanish G, and I configure the port 5 for this one. For the F0 slash here. Okay, so now what happened here? If I connect the PC to the F0 slash 6, see, I don't have to wait. I don't have to wait for the 50 seconds here. You see, it's internet going up here. You don't have to wait for the 50 seconds here. So they call it the rapid Spanish protocol. And remember that you only configure the port in the case you connect to the computer only, not in the case you connect to the street here. Okay, so now you know that in order to prevent problem of single point failure, right? You can use a redundancy, but in the case of redundancy, you have problem with the traffic loop here. So in order to prevent the traffic loop problem, you work with Spanish protocol here. The Spanish protocol is a protocol to have a long process and to decide which is the link you have to block it in order to prevent for the looping here. And remember that blocking is only temporary. Any change in the topology, the NTP can adapt it and bring up the blocking port here. Okay, now we move to the switch for security here. So what is the switch for security? That is what I have here. Yeah, for security here. Okay, so now we move to the definition of the port security. So by default, right, when you work with a package service, when we have the switch and you just plug in the PC, you're able to communicate to everyone on the network here. You see, that is not good practice of the security here. Whenever you have the computer and you plug in to the port of the switch, you're able to communicate to other computer here. It's not good. What happened if we have the bad guy? He just plug it in the port of the switch, and now he able to communicate and to do the bad thing with the network here. So here's the thing: you have something to do with the port security in the switch here. They call it the port security here. So think about this one. Normally for the switch here, for the switch, simple switch here, you have the 24 port. You have 24 port. So by default, all of the 24 port here are active. So whenever we plug in the cable, you instantly able to communicate to other computer here, right? Not good. That's not good here. So if you are the network administrator, you have to know for sure which port you want to activate it and which port you want to deactivate it here. So think about this one here. You see, I have the 2 port here, F0/1 and F0/2 and F0/3. I know for sure this one connect to the one employee, right? This one here to connect to another employee, and this one here interconnect them the three together, right? So now, the first step to enhance the security is that I have to shut down all of the remaining port. I see, I have to shut down all of F0/3 here, or all over to F0/4, 3, 1, 2, 3 here, right? So I have to shut down every port F0/4 to the F0/24 here. That is the first step. That is the first step of security here. So that's why you can go to the switch. You can go to the switch and you can go to and F0/4 to 24. You put the shutdown command. Okay, so I think there's something wrong here because the shutdown here is invalid input. Okay, so let me do it again. Shutdown. Sorry. I delete this one first. Okay, so see, now if I shut down, right? I shut down every port from F0/4 to F0/24 here. So what happened here? I connect the PC, I connect to whatever port, remaining port here. So see, I connect to the F0/15. I have no way. I have no way to access to the internet here. Sorry, to the network here. So that is the first step of the switch port security here. Remember that whenever you know for sure each port you are not using, shut it down. So we see when you have the bad guy here, he want to connect it. He want to connect it to whatever port it here. You have no way to activate the port here, because it already shut down manually shut down by the network administrator here. So that is the first step. So you can have another step here. If you remember about the case that we mentioned about the ARP, right? ARP here. ARP here. Do you remember what is the ARP and why you need to use the ARP? Any idea? Any idea?
Did you say ARP?
Yes.
Isn't that a family of commands that have something to do with network caches?
Yeah, right. That also. So ARP here is address resolution protocol. Address resolution protocol. So think about this one. If you want to send from 192.168.1.1, you send it to the 192.168.1.2. Right? You see, in order to deliver to destination, you have the process of encapsulation here. So you have to put it down. What is the destination MAC address? What is the source MAC address? And what is the source IP address? And what is destination IP address? So in that case, the IP address here, you know, IP address here, you know for that one. And the source IP address, sorry, the source MAC is your, you know it. But in the case that you know the IP address is 192.168.1.2 here, but you don't know MAC address of destination. In that case, you have to use the ARP here, address resolution protocol. You send it out to everyone. You send it out to everyone to the switch, and switch you plot it out to everyone. And this guy is the one who reply you. I am 192.168.1.2, and you can use my MAC address here. Only after that he can send it to destination here. So one problem with the switch here also. One problem with the switch they can do with the MAC spoofing here. Sorry. MAC address spoofing. That means he fake MAC address here. The fake, he do some fake MAC address here. So in the case that you know that in order to deliver to destination, switch always maintain the MAC address table. MAC address table here. MAC address table. MAC address table in that. What do you think? What do we have in the MAC address table? What do you think? Do you remember it? What do you have in the MAC address table? What do you think? Any idea from you guys? What do you have in MAC address table?
You have the list of recently resolved MAC addresses to their host names on the network.
Okay, so you have the MAC address, right? You have MAC address and now
And IP address.
sorry. No, not IP address. Remember that switch is a layer 2 device. Have no idea what is the IP address here.
Host name?
No, port number. Is a port number here. So see, it maintained here. Know that you have the CD71 connect to the F0/1 here, right? To make it simple, I just put here CD71 and connect it to the port number 1, right? And you have the 7C79 here, connect to the port number 2. The MAC address here always maintain the mapping between the MAC address and the port number. So see, if this one here sent to the switch, right? Switch look it up here. Destination here 7C79 matching with the port number 2, and he forward it to the port number 2. That is the way the switch do with the switching here, right? It always maintains the MAC address table, and MAC address table is the mapping between the MAC address and the port number. He always look at it in the MAC address destination here, and he knows that in order to send to this guy here, he had to deliver, he had to forward it out of the port number 2 here. It makes sense? Hello?
Yes.
Yeah.
Now, but in the case of the switch, you have problem of the MAC address spoofing. That is MAC address spoofing here. Sorry. Spoofing, that means he generates the fake MAC address here. And remember that the switch here, the switch always learn and update the MAC address table from incoming traffic. So see, when this guy here send the frame to the switch learn it, right? He knows that now I have to update CD71 and the port number 1 here. That is the way switch maintain the MAC address table. It always learn it from incoming traffic. He look it up. He knows that this frame here is the address is CD71 updated here and matching with the port number 1. Basically, it works with the incoming traffic here. Now, in the case of the MAC address spoofing, this guy here, he generates the fake MAC address. So for 1 second here, he can generate 100 or 1,000 MAC address here. I think what happened here, one time we have the CD71, the other time he have ABCD, and the next time he have the CD, E, whatever. Right? So see, very soon. Very soon here, the MAC address here, it update every MAC address with the port number 1 here, and every soon he overloaded. Very soon he overloaded. So we see, you think about it, 1 second here, he can generate for 1,000 or 10,000 of MAC address here. Very soon, the MAC address here, a table in the street overloaded. So in the case of overloaded, the switch send it out to everyone as a broadcast here. So remember that in the case send it out to everyone, it's a huge problem of security here. Right? Everyone can see what is going on in the network. Right? So in that case, you can do with the port security here, port security. So at that time, you can limit it. You can limit the port here in the F0/1 here. You can limit the port F0/1 here. You only allow it for maximum of 5 MAC address table, 5 MAC address away at one time. I see if you don't limit it, it can store for 1,000 or 10,000, and you can overload it, the MAC address table here, right? But now if you configure it with the port security here, you will only limit it for the 5 MAC address only, right? So we see if he hits this one here, he generates the 5 MAC address, and when you come to the 6, the port will be shut down, and you have no way to do with the spoof MAC address here. It makes sense? Okay.
Yeah, that makes
Yeah.
more sense now.
Right? See, when you learn it too much, update it in MAC address table, overload it, totally overload it. Yeah, right? So now when we talk about the port security, the first step you have to remember that you have to shut down every port. You don't use it. Right? The second one, you can limit on the MAC address learning here process. And the third one here, is that you know for sure here, this port here, F0/1 here. I know for sure the F0/1 only connect to the single computer and dedicated computer. You think about this guy here, CEO here of the company, right? And you know that what is his PC? Sorry, what is PC and its MAC address here? It's a dedicated MAC address. So in that case, you can dedicate it. The port here only connect to the PC, it works. But any other PC, when you connect to the port here, it will be shut down. So in that case, you have to work on the MAC address here. Now let me simulate it here. See what happened here. So we can think about this guy here. I know for sure this guy only computer with the MAC address CD71 here connect to the F0/1. Right? So I can go to the PC. I check what is MAC address here. What is the MAC address here? I copy it. I copy the MAC address. I copy the MAC address and I go to the switch. F0/1 here, and I put the port. Switch port. Yeah, I put the MAC address here, and I put the MAC address here. I paste it. Okay. Oh, I had to put switch port positive first. Sorry. What is it? Okay. Switch port. Okay, switch port. Sorry. Okay, so now I should port possibility. Oh, why? Okay, so now I activate the port possibility, right? So now I make sure that only the port F0/1 to connect to the MAC address here only. Right? So now what happened here? What happened here? If I plug out the computer here, I delete the computer here, or I said delete the cable here. Now I have to think about another computer here. Of course, you see, when I have another computer, the MAC address is not the same. MAC address here not the same. What happened here? I have computer and this guy try to connect to the F0/1 here. I have to connect the IP address for this one. Okay, so now let's see if I configure the IP address and he want to communicate to other PC here. What happened here? 192. I do the same 168.1.1. port. So now see, right after the config IP address, right, and right after I have some action to ping and to have the incoming traffic to the street, the port will be going down because this one here I only config for the MAC address of this guy only. Right? So whenever you plug out the another computer and you plug in the another computer here, the MAC address not the same. That's why the port going down here. Right? Make sense?
Yeah.
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 So remember one thing here. Remember one thing here about this one. For every PC, you have specific network interface. And when you have specific network interface, you have the specific and unique MAC address here. Right? So when I configure this interface F0/1 here, for only Unix MAC address here, right? So whenever you plug out and plug in any other computer, the MAC address is not the same. That's why when I connect it to the F0/1, the port is going down here, right? For sure, that's only the PC from the CEO guy here able to connect to the F0/1. Okay, so that is something you are able to configure for the port security. Remember that you have something here. The first one, you have to shut down the port if you don't use. The second one, you can set the port security and you limit the number of the dynamic MAC here, MAC address, so we can limit it to 5 or 10 to prevent problem of the spoofing here. And the third one, you can configure the port security with the specific MAC address here. So for this one here, you have only configured for working with this one. Okay, so now we go with the hierarchy design. So basically in the network, if you have the good topology here, they break it down into they break it down into 3 layers of the design here. They call it the 3-tier architecture here. So this one is you can break it down into 3 layers. You can break it down into 2 layers here. So we see this one is 1 layer, this one another layer, and this one another layer. And the purpose of that is that it enhances the problem. It can enhance the capability of the redundancy here and enhance the capability of the working with the network here. So this one here, they call it the access layer. The access layer is that where you connect to the end device here, computer here, right? So from the access layer, you see, when you go to the distribution layer here, you have more redundancy. I see when see for this one here, when this one going down or this one going down, you still have the another layer. You can redundancy. So distribution layer here is everything working redundancy here. You can see this one when you interface with the end device here, and this one is a core layer. Core layer is when you work with the fast switching and you interconnect to the another network here, the backbone here. Okay. Okay, as a new technology such as virtualization and software-defined network and cloud computing become more significant latency. So this one here, design need to better optimize for the each and one traffic. Each and one traffic, that means you have on the same layer here. So from the switch here to the switch here, they are on the same layer. They come from east to west. And the other one can have the north to south. Yeah, this one, so north to south here. So whenever you come from the another layer to the another layer here, the core is the north to south here. Now we come with the definition of the software design networking here. The software defined network is a centralized approach to networking. So remember that thing about when you have the network here, right? Think about you have network, you have the one router 1, you have router 2, and you have the switch number 1 and the switch number 2 here. So basically, you see, if you don't have the centralized control network here, whenever you want to configure for the router or the switch, you have to manually go to the switch, you have to manually go to the router, you have to manually go to router, switch, and router, and you have to configure for what is the username, what is the username and the password for every single piece, sorry, for every single router and the password here. It's not good. What think about if you have the network, you have 100 of router and 100 of the switches here. It's not good for the management, right? So in that case, you have the dedicated network here. It is centralized approach network here. So in that one, we have the software-defined controller here. It is the one who manage all of the this one here, manage all of the switch and router in the network. So in that case here, you only need to configure the username and password one time only for every router and the switch here. So see, if you are the end user here, when you go to the switch number 2, what is your username password? You will look into the dedicated device here. And so when you go to the router 1, what is the username password? You look into the dedicated device here. You don't have to manually go to every single router or the switch to configure for the username and password here. Okay. So for the SDN here, it breaks it down into the different layers here. The first one is the infrastructure plane. Plane is the core, is the data plane. It's where you exchange the frame together. You can exchange frame together here. And the second one is the control plane. Control plane is where you handle about decision making, where you control, where we set up the configuration. What is the username and password here for each of the router here. Okay. As I see, you can break it down in control plane and infrastructure plane here. So we can think about infrastructure plane is that where you have a port here, right? So when you send from the PC1, you forward it to PC2 here. It's everything about the infrastructure plane. That about the data here, how we exchange data together. But for the control plane here, you have everything about spanning tree protocol. You have ARP, and you have information about how you set up the username and password here. And for this one here, they move everything with the control plane. We move everything control plane into the dedicated server here, the SDN. So we said you need to configure it in that SDN only. You don't have to go to every single device to configure for the control information here. Now I think you have this one here.
SDN is a relatively new way to think about building and managing today's networks. With SDN, we've taken a traditional device and we've broken it up into smaller pieces. For example, let's look at a switch. The main function of a switch is to be able to forward frames from one interface to another based on the destination MAC address. But we also have configurations that are required. We need to log into the switch, and we as the network administrators need to be able to administer the switch. This is where we start to break out the different pieces of a software-defined network. You have a control plane that's responsible for the administration and the ongoing servicing of that particular device. And then you have a data plane that's responsible for transferring or forwarding data from one point to another. One of the key features of an SDN is that it's directly programmable. This data plane is completely separate from the control plane, so you can make configuration changes or look at log information, and that's a completely separate process than the ongoing operation of the data plane. SDNs are also agile. That means that we can make changes on the fly at any time. If an application flow suddenly got busier in one part of the network than the other, the network can automatically and dynamically change itself to provide more capacity where it's needed. Another property of an SDN is that it's managed from one central console. You don't have to log into multiple places to be able to manage your network. We call this type of management a single pane of glass because you can sit in front of a single screen and be able to control the entire network. Another useful property of an SDN is that it can be orchestrated. This means that you can programmatically configure how things occur on the network, and often this can be done automatically. For example, an SDN may be constantly monitoring part of the network, and if the network becomes congested or needs more resources, those resources can be deployed automatically. And another key property of an SDN is that it's vendor neutral. You don't have to have 100% of any particular vendor's products, and generally a lot of the standards associated with the control of this SDN are publicly available as an open standard. A lot of this SDN functionality is enabled because we virtualized a huge portion of our infrastructure. We have servers and routers and
okay, so the thing about the purpose at the end that you separate it between the data plane and the control plane here. Right? So in the case of control plane, you have the single dedicated server you control for every device on the network here. You don't have to go to every single device to configure for the control information here. Okay, what else? Now we have the storage area network. The SAN here. Storage area network is a network of storage device that can that communicate directly with each other and the other portion of the network. The SAN device contains multiple storage drives and are designed to make the data available to the network server. Okay, and in order to maximize the throughput, the SAN rely on one of these networking technology. You can use a fiber channel, right? So you know that we learn from the fiber channel. Fiber channel, we have the higher bandwidth, and the total immune to the external interference here. You total immune to the electromagnetic interference and total immune to the radio frequency interference here. Or you can use a fiber channel over Ethernet, or can have Ethernet SI here, or can have infinity band here.
Time tracking is fun, said no one ever. That's why we designed Connect Team's time clock to simplify
data. Now, a SAN, or Storage Area Network, is a special high-speed network that stores and provides access to large amounts of data. So basically, it's a dedicated network that's used for data storage. And this network consists of multiple disk arrays, switches, and servers.
Okay, so we see the name, right? Storage Area Network. So the main purpose here is that we want to store the huge amount of data here, right? And it's just going to maintain the huge amount of data. You make sure that you have the higher availability here. You have the higher bandwidth connection here, and you have the full of the redundancy here. That's why you work with the RAID, right? You know the RAID, right?
And because it has more than one of these devices, a SAN is fault tolerant, and the data is also shared among several disk arrays. So if a switch or a disk array or if a server goes down, the data can still be accessed. And when a server accesses the data on a SAN, it accesses the data as if it was a local hard drive, because that's how operating systems recognize a SAN. It's recognized as a local attached hard drive rather than a shared network drive like in a NAS. And SANs are also highly scalable because adding more storage space can easily be done without an interruption on the network. So as stated before, a SAN is a high-speed network, and that's because in a SAN, all the devices are interconnected, meaning that all of the devices are connected to each other, and they are interconnected using fiber channel, which is a standard for SANs. Fiber channel is fiber optics, and it has speeds between 2 gigabits per second all the way up to 128 gigabits per second. So fiber channel is extremely fast, and it's also very expensive. And most SANs today use fiber channel. But also as an alternative to fiber channel, some SANs use iSCSI instead, which is a cheaper alternative to fiber channel, but it's also not as fast as fiber channel. Now, one of the main reasons for using a SAN is because SANs are not affected by network traffic, such as bottlenecks that can happen in a local area network. And this is because SANs aren't really a part of a local area network. SANs are partitioned off. It's basically a network all by itself. And other reasons for SANs, as I mentioned before, SANs are highly scalable and they are also very redundant. And also, as you might have guessed, SANs are not cheap. They come at a very high cost, which is why they are mainly used by large companies and large organizations.
Okay, so the SAN is a dedicated network, right, to store the huge amount of data. And in that, so you have to make sure that you have everything with the redundancy here. I see you have the redundancy here. If the link going down, still have any another link here. And also for each of the server, you have to working with the red, right? You know the red, right? I believe that. The red, redundancy arrays. Let's see, what is redundancy arrays? What is the definition for that? That red, that means when we store in the drive, right? Instead of the store in the one drive, you can duplicate it into another drive here. So one going down, we still have the another one to make it up here. Okay, so we see you can use the fiber optic, or nowadays you can use the fiber optic. You have the more bandwidth and you have more reliable when you work with the fiber optic here. What is this one? Okay, now we move to the virtual architecture here, and nowadays we do a lot of virtual architecture, right? You heard about the virtual box, right? VMware here. So see, you can have actually you can have another computer inside your computer here. Right? So the virtualization is a virtual or logical version of something rather than actual or physical here. Right? So see, the name tell it. The name tell it here. This one is the virtual or logical. This one here, it is virtual or logical, not physical. Right? It is virtual or logical here. It's not actual or the physical here. Right? And a host is a physical computer hosting a virtual machine. So in order to have the virtualization, you need one physical computer, right? You need at least one physical computer, and the core is the host here. And the host is a physical computer where you can host a virtual machine or the multiple virtual machine here. And the guest is each of a virtual machine. So if you have a dedicated physical computer, you can have the multiple, not only one, right? You can have the multiple virtual machine on that one here. And in order to do that, you have the hypervisor. Hypervisor is the one who create and manage virtual machine here. It also manage resources allocation and sharing between the host and any of the guest virtual machine here. It manages resource. What is the resource here? What is it? What's the resources here? Manage resource allocation here. What do you think? What is the resources here?
Things like memory and storage and processing power.
Mm-hmm. That's all, right? For every computer, you have the processing, right? Or you have processor, you have memory, and you have storage, right? And the hypervisor here is the one who manages resource allocation. I think about if you work with the virtual machine, how many RAM you can allocate it for that, right? What is the storage here and the processing here? And you have the two types of the hypervisor. The first one is the type 1, is installed on the computer before this one here. You have before any operating system, and it's called the bare metal hypervisor. The second one is the type 2. It's installed on the host operating system at the application, and it's called the host hypervisor here. And the type 2 here is the most common, you can see, right? So basically, you see, you have your computer here, and you already have the window, right? You have window on that one, and based on that, when you have the operating system here, you can install and download VirtualBox or VMware, and in VirtualBox and VMware here, you can install the Windows or Linux based on that. Right? And the type 2 here is the most common one we see.
What? Lipstick? Uber Eats.
In this video from IT Free Training, I will have a look at the two types of virtualization solutions that are available on the market. These are referred to as Type 1 and Type 2. Type 2 virtualization systems work like this. You have the hardware layer and the operating system on top of this. If you decide to run a virtualization solution, this is installed on the host operating system. When it is installed, it will install a hypervisor on the host operating system. Any virtual machines that are run on that computer are attached to that hypervisor. You can see that a virtual machine, in order to access that hardware, must go through the hypervisor. The hypervisor will then access the operating system to provide that functionality. The operating system will then access the hardware. Performance is slower in Type 2 virtualization solutions because of this. The advantage of Type 2 is that they are simple to run and install and don't require any special hardware features in order to run. Type 1, in contrast, works like this. On the hardware layer, the hypervisor is installed on top. The difference with Type 1 is that the operating system runs on top of the hypervisor. If any virtual machines are installed, they also run through the hypervisor. Type 1 virtualization offers better performance than Type 2. However, often Type 1 will require certain hardware features. For example, require virtualization to be supported in the CPU and be enabled in the BIOS. Type 1 virtualization solutions include Hyper-V and vSphere. The advantage of Hyper-V is that you can run Windows as well as the virtualization solution. With vSphere, you require a dedicated server to run the virtualization. The other option is to run a Type 2 virtualization solution. These include Microsoft Virtual PC, Microsoft Virtual Server, VMware Workstation, and VirtualBox. The advantage of these is that they do not require a dedicated computer or special hardware in order to run. Before finishing this video, I just want to clear up one point in regard to Hyper-V. Hyper-V is sometimes mistaken for a Type 2 virtualization solution since an operating system is required in order to run Hyper-V. If you take an example of an install of Windows Server 2012 R2, a hardware abstraction layer, or HAB.
Okay, so we have the Type 1 and Type 2, right? You see in the Type 2, right? The Type 2, you have installed the hypervisor on top of the hard operating system here. You already have the operating system. But in the Type 1, you have the hypervisor on top of the hardware only, and on that you have the separate operating system here. Okay, so in the virtual machine software and hardware characteristic aside when you create in the hypervisor here. So we think in the case if you work with VMware or if you work with the VirtualBox, right? See when you install the Windows only here, you have option, right? Whenever you create the virtual machine here, you have option to choose how many memory you want to reserve it and how is the storage here. So it can be customized based on the guest OS, amount of memory, hard disk size, and processor type, and other options. Now we move to the network connection type. So basically, you have the three types of network connection. The first one is a bridge mode here. Connection type, normally you have the three types of the connection network connection type. The first one is a bridge mode. In the case bridge mode, a virtual network interface card here access to physical network, right? So you see, it access to the physical network here using the host machine, the network interface card here. You see, for every the virtual, you have the virtual switch interconnect, right? In the case that you have one more than the virtual machine here, you have a virtual switch, and you interconnect them together. And in the case of bridge mode here, so every computer here, it connected to the physical network, right? Think about you connect to the outside network here. Whenever you want to connect to the outside network, you go through the physical network interface here, right? And it obtains all IP address, default gateway, subnet mask from the DHCP server on physical LAN. You think about this one here. Now, if you think about you have the home internet, you have a home internet. Remember that the home router here. The home router is you have many functions with the home router. It can be the switch. You see, you have multiple ports to connect to the wire connection. It can be the access point for the wireless access. It can be router also, right? Router is interconnect to the internet, and it also works as a DHCP server. DHCP server is a dynamic host configuration protocol that gives you the IP address automatically. You see, when you work with the home network here, you don't have to manually configure your IP address. Basically, it got it automatically from the DHCP server here. So in case of bridge mode here, each of the virtual machine, it got the IP address, it got the default gateway and the subnet mask from the DHCP server on the physical LAN. So if you have the home router here, every virtual machine here connected to the connected to physical router with physical DHCP server here to get the IP address. So in that case, you see, if you look on the IP address here, 192.168.1.18.2 and 133 and 131, everyone here, they are on the same network. You see, all of them here, right? Have the same rate here, 192 here, 168 here, .1. They have on the same network because they work exactly the same with the physical computer here, connected to the DHCP server and got information about the IP address, the subnet mask, and the default gateway here. All right. So see, the virtual machine appear to other node as just another client. So from the another machine here, they look at the virtual machine. They can think that they are exactly on the same network here, right? Because the IP address here is the range here the same. Now, in the case of the NAT, that means the network address translation mode here, NAT here. In the NAT mode, virtual network interface card rely on the host machine to act as the NAT device here. Remember, the NAT, that means the network address translation here. I mean, you got it, right? You got it here. You obtain the IP address information from the host, not from the actual DHCP server. Right? You see the difference here. You got the IP address here from the host, from the network interface card host. That's why you see the IP address here, they are not on the same network. See, it's for this one here. You work with the physical DHCP server, you have them on the same network. But this one here, they are not on the same network. Right? So see, this one is the same network here. And normally, the hypervisor here has a DHCP server, and you got it from the physical network interface card here. And this type, the connection is appropriate for the virtual machine that don't need to be accessed at the known address by another network node here. That is the thing you use the network interface card here. Sorry, network address translation here. So see, if you want to access to the virtual machine here, if you want to access from external network here, if you want to access to virtual machine, you have to go to the physical network interface card here. You have 192.168 and .1.131 here. You have no information about this one. So this one here, it works very good in the hiding information of the network. So if you look on from external here, the only thing you know it is a physical network interface card here. You have no information about the information about IP address or the subnet mask for this one. But you see, for this one here, if you look from the external, right? You see, you can see directly what is it? 192.168.1.132. This one, they are on the same network, and you don't hide anything. But it work better in the performance here. This one, anytime if you want to go to the external network, you have to translate it. You have to translate from the IP address here. You have to translate it to the physical network of the network interface card here. Now the mode number 3 here is a host only mode. So in the case of host only mode here, you only got the IP address from the virtual DHCP server in the hypervisor. You have no way to connect to the physical address. You have no way to connect to the physical network interface card, and you have no way to connect to the external network. You only confine in the virtual network only. Right? For this guy here, you have no way to go out to the internet. Right? And it depends. This one here, the when on the network can exchange with each other and the host here already. You only have no way to go to the internet here. And they cannot communicate with the node beyond the host. And the virtual network interface card never receives the transmit data with the host physical network interface card here. And it depends on the scenario. Something you need something about security, and you don't want to go out to the internet. You can configure with the host only mode here. Okay, so I think I have this video here.
Hello, and this is Sunny. Virtual machines can communicate with each other on the host as well as other physical machines on the physical network. To do so, virtual machines need two virtual things: virtual NICs and virtual switches or bridges. A virtual switch is a logically defined layer 2 device that passes frames between nodes. Virtual NICs of virtual machines are connected to the virtual ports on the virtual switch, which is then connected through the host physical NIC to the physical network. The basic principle of network communications is the same, whether they are virtual or physical. Virtual switches are just like physical switches. Each virtual switch creates a separate broadcast domain. To connect two broadcast domains, we need a layer 3 router. Now let's talk about virtual machine network connection. There are basically 3 network connection modes when we set up virtual NIC for virtual machine: bridged connection, NET, and host only. In the bridged connection mode, a virtual machine connects to the physical network directly through the host physical NIC. In this mode, the host NIC is a bridge to all these 3 virtual machines. Just like their host and other physical computers, virtual machines obtain IP addressing information from a DHCP server on the physical network. When connected using bridged connection mode, a virtual machine...
So you see, they connect to the physical DHCP server, right? That's why the IP address here exactly the same. And from the computer here point of view, when he look in the virtual machine, he can think that they are on the computer on the same network. Exactly, they have no idea which one is the virtual machine, which one is logical here, right? So you see, every computer here they have the same IP address or same range, 192.168.10 here, .10 here. Right? Exactly the same because the way it works is exactly the same with the physical. It got it from the DHCP server here.
Machine appears to other nodes as just another computer on the network. This example shows that virtual machines are connected to the network through the host-only NIC. However, we can install physical NICs for each virtual machine. Each virtual NIC gets a connection to its own dedicated physical NIC. In the bridged connection mode, these virtual machines' IP addresses are visible and directly accessible by other computers on the network. Thus, good candidates for these virtual machines can be a mail server, or file server, or a web server. The second connection mode is Network Address Translation, or NET. In this mode, virtual machines rely on the host to act as a NET device. With the NET mode, virtual DHCP server is responsible for assigning IP addressing information to these virtual machines, and they form a private network. Other machines on the physical network are getting IP addressing information from the physical DHCP server. They form an external network. The host is sitting between these 2 networks and translates the IP address from a virtual machine to the IP address of the host. It also listens for returning traffic so that it can deliver it to the virtual machine. The external physical network sees traffic from the virtual machine as if it comes from the host itself. The NET connection type is appropriate when virtual machines are mainly used as the client workstation to check emails or surf the internet. The third connection type is host only. In this mode, virtual machines on the host can talk with each other and with their host but they cannot communicate with any other computers beyond. This connection mode is useful when we set up an isolated private virtual network where we can have cyber attack experiments. Within a constrained host-only environment, we can avoid leaking out packages into our normal network.
Very straightforward with the video, right? Like, simple. Any question? Hello?
No.
Okay. So just remember you have the three types of connection here. Bridge mode. Directly got the IP address from the DHCP server. And from the point of view, it works exactly the same as the computer here. The second one, the network address translation. So when you go to the internal network, you have to translate it. And from the internal network, you look into the network here, you have no idea about that. You only know what is communicate with the network physical here. And the third one is an isolate network here. It only isolate inside the virtual network here. It have no way to go to outside. Okay, so now you know that you have the sum of the benefit. You only have one single computer here, but at the same time you can have the multiple virtual machine here. You see, you have the sum of benefit inside. But also you have the sum of the each advantage with the virtualization here. Can you name someone? What is the each advantage of the virtualization? What do you think? What do you think?
Could you repeat the question? I didn't hear it very well.
Sorry, I have to, yeah. So we see you have the sum of a pro, right? You see you only have need one single physical computer, but on top of that you can set up the virtual network here. But also you have the sum of the each advantage of the virtualization here. Can you tell what? Can you name some of the advantages? Each advantage of the virtual network here, virtualization here.
The first one comes to mind is you could have a computer with virtual machines with different operating systems. So you could technically have like Linux, Windows, and whatever they call Apple's operating system on one PC, though two of them would be on virtual machines.
Right. That is the advantage, right? Right? Yeah. So what is the disadvantage here? What do you think? What do you think? What is the disadvantage of the virtualization? What do you think?
That you can add resources into it.
What?
You can add resources into virtualization.
So that is the advantage or disadvantage. What do you think?
What?
Okay, so now we talk about the virtualization, right? You have the sum of the advantage already, right? With sum of the pro already. You see that on top of the physical computer, you can have the multiple operating system or multiple virtual machine here. Right? That is advantage here. Now you have or you can have a pro here. And for the cons, what do you think? What is the disadvantage of the virtualization? For the con here, what do you think? What do you think? You can see clearly that you have the sum of the pro already, right? But what about the cons here? I see. What happened if you have the physical computer going down? Everyone going down, right? We call it a single point failure here. So what happened if you're going down or the power, you have lots of power, this virtual machine here going down, right? Of course, you have a lot of disadvantage in the virtualization here, because you see, everyone has to share resources, right? You have to share about the memory, you have to share about processing, you have to share about the storage. Also, right, degrade the performance when you compare to single dedicated computer here. So see, you can see on this one, you have the sum of pro and con of the virtualization here. Of course, you have the sum of advantage here. It's efficient use of resources. For one computer, you can have the you can break it in. Sorry, you can create a multiple virtual machine here, right? The cost and energy saving, right? A lot of things. You have a pro and the threat isolation and simple backup and recovery and replication here. But of course, you have some of the disadvantage here. Compromise performance. Everyone have to share the same resources, right? And you have to increase the complexity here, increase the licensing cost. Of course, when you work with the window, you also need to license for the window here, right? And single point of failure here. What happened if the computer, the physical computer going down, everyone going down, right? Okay, so now you have about the virtualization for the computer, and now also we have the network virtualization also. You not only have the virtual computer, but you can also have the virtual router, virtual switch, and virtual firewall also. It provides a flexible and cost-saving option for many type network here. You can have the virtual firewall, or you can have the virtual router also. And of course, you have some advantage of virtualization network function. Virtual device can quickly and sometimes automatically migrate from the one server to another. You see, you can do based on software only, right? Everything on software. You don't need the dedicated physical router or the switch here. And the resources are utilized more efficiency, and so it can be easily scaled to meet the change and need of the network here. Change this one.
Many service providers go beyond simply providing network connectivity for their enterprise customers. They also offer additional services and network functions like network address translation, firewalls, encryption, domain name service, caching, and others. Traditionally, these network functions were deployed using proprietary hardware at the customer premises. This approach provides additional revenue, but deploying multiple proprietary devices is costly and makes upgrades difficult. Every time a new network function is added to a service, a truck roll is required to install the dedicated hardware. Service providers began exploring ways to reduce cost and accelerate deployments through network function virtualization. Network function virtualization, or NFV, decouples functions like a firewall or encryption from dedicated hardware and moves the function to virtual servers. Instead of installing expensive proprietary hardware, service providers can purchase inexpensive switches, storage, and servers to run virtual machines that perform network functions. This collapses multiple functions into a single physical server, reducing cost and minimizing truck rolls. If a customer wants to add a new network function, the service provider can simply spin up a new virtual machine to perform that function. NFV refers to the strategy of virtualizing network functions, moving from separate proprietary pieces of hardware to software running on virtual servers using standard hardware. Virtual CPE commonly refers to any network.
Okay, so to make it simple, is understand that back then here, if you want to set up the network, you have to dedicate the server, right? You have to dedicate the router, you have to dedicate the firewall, and you have to dedicate the switch, and many dedicated device, right? So you see, you have to buy for the server, you have to buy for the router or the switch here. Each of them is a single physical device here. You see, upfront you have to pay a lot of money for upfront here. Also, we have to pay a lot of money for the space. You have a lot of space and operation here. But now, if you can move it to the virtualization, just think about this one. When you move to the virtualization, you only need one single server only. One single server, dedicated server, right? And on top of that, you can install the virtual firewall, virtual switch, and virtual router here. You see? Now, instead of spend a lot of money on every single device here, now you need only one device. one single server, but on top of that, you can install based on the virtual machine, virtual firewall, virtual switch, and virtual router here. And it's very easy to scale up. So think about if you need more device, you can install more virtual machine here. Right? So basically, that is a benefit of the network function virtualization. You can move from the dedicated physical device into the virtualization here. Okay, so you have the cloud architecture, you have the cloud computing, refer to a flexible provision of data storage application and the service to multiple clients over the network. And cloud computing feature includes the following on-demand service, pay-as-you-go, right? You can think about pay-as-you-go. You have the broad network access, you have the resources pooling, you have meter service and rapid elasticity here. Cloud computing is a lot nowadays. I can use the Google Drive. That is also the kind of cloud computing, so we can go anywhere. You don't care, right? Providing that you have the internet access, you can access it to anywhere. What? Anyway, we know that how the cloud computing works here. Okay, so now we have a cloud service model here. So cloud computing service model can categorize by the type of the service provided. So back then, right? Back then, you know that on-premises. On-premises, that means you have every hardware, right? You have to pay in upfront here for every server, for every switch and router here. And on-premises is all the hardware and the software and everything else are located and managed at the organization location here. So you think back, you have the dedicated data center. You have the rack. On that, you have the server, you have the router, on the switch, you have many devices on that, right? So when you move to the cloud, you have the three types. You have the three types of the cloud service here. The first one is the infrastructure as a service. The second one is platform as a service. And the third one, you have the software as a service. And now they also have anything as a service also. So basically for the infrastructure as a service, that means you rent out, right? You rent out everything about the hardware. I think about you rent out hardware about the network infrastructure here. You rent out about the router, the switch, or the server, everything. But on top of that, the operating system here is maintained by you, and every application here maintained by you. So for the platform as a service includes the operating system, right? And you have the runtime library module of the OS provides the application here. And the third one is the software as a service that you don't have to do anything. Application as a provide, you don't have to do anything. You think about the integrate email here, right? You don't have anything to maintain here. And in the cloud model, you also have some type of cloud. Public cloud is a service provided over the public transmission line. Yeah, it's a public. They have the private cloud. The service is set up on the organization own server and its own data center, or you have a community cloud, or you have the hybrid cloud. It's a combination of both of the public and private here. What else? Okay, and of course, when you work with the cloud, you have the problem of some problem here. The first one, what if it's the internet service provider outage, right? So see in that case, you are not able to access the data. Right? The thing is that when you work with the cloud, you need to access to the internet here. You need to how to access. But what happens if the internet service provider outage? What happens if the cloud provider outage here? You also have a problem with the security here, right? Because they are not managed by you, managed on the public networking. Okay, so in order to mitigate or reduce the risk risk here on the computer, you can use encryption, or it can choose a method in which you network connect to the cloud resources, or you can consider some of the following method. Internet, you can use a virtual private network. You create a tunnel here, You can remote access connection instead of using the telnet, you're using the SSH here, secure shell with more secure, or you can list line here that you have the single line by you. You don't have to share to anyone here, or you have the dedicated direct connection here. Okay, you have the network ability definition. A network ability to refer to how consistent and the reliable of the file or system can be accessed here. And we have the high ability refer to system that function reliable near on the device. So fault tolerant, everything about redundancy, right? You see, you avoid problem of single point of failure here. And you have some definition about the MTBF and TTR here. MTBF is the mean time between failure. It's average amount of time that will pass for the device exactly lies one before the next failure here. So what is the duration between the average of the two failure here? And mean time to repair, that how the duration you need to take to repair it here. Okay, so I think that's all in the slide here. And you have in the case of fault tolerant, you have to work with the redundancy. In the case of redundancy here, you have the two approaches, the hot spare and the cold spare. Hot spare, that means in the running time, you can plug out and plug in the spare part and no impact the server here. In the cold spare, that means you have to shut down. You have to shut it down, the server. Or okay. Now in the case of fault tolerant also, right? So remember that in the case of the loop working with the loop, right? Yeah. Think about this one. If I have you have the two switch here. I have two switch here. So basically, I connect the two switch together by the path Ethernet here, absolute port here. Right? So think about I have one link to connect the two switch together. So if I have one link to connect the two switch together, it only support for 100 megabit per second here. Think about you have the path Ethernet here. So what happened here if I want to increase the bandwidth from the 100 megabit per second here to think about 800, right? 800 megabit second. So in that case, I need the 8 cable, right? 1, 2, 3, 4, 5, 6, 7, 8 here. But the thing here, you see, when you have the 8 cable connect them together, you have problem of looping here. You see what happened here? Send it to switch, send it to here, and send it again and again here. So you know that in that case here, if you work in the spanning tree protocol, you know that when working with spanning tree protocol, think about you have a two line here. It only block for one line to prevent problem of looping here. You think about this one. Even that you have the 3 line here. It only blocks the 2 line. So basically, you see, you have no way to increase from the 100 megabit per second because basically it only one link working. So in that case, you have to work with the link aggregation here. So the switch group or the link here together as a logical link, one logical link. They group them together as a one logical link. So from the spanning tree point of view, you can see that all of the line here at a single line only. So all of them is open here. So you can prevent problem of the looping here, and also you can aggregate them together. So by using the 8 line here, you can increase the bandwidth here from the 100 to the 800 here. So we see it can increase the total throughput here, and also you have automatically failover. So see when you group them together, right? So one link going down, it doesn't matter because you have a lot of redundancy here, and ultimately load balance it distribute evenly between the link here. Okay, so see in that case, you just group them together, right? You just group them here together. So instead of 100 megabit per second, now you can increase it to 200 here. And of course, in the anything is going down, you still have the redundancy here. Okay, so the fault tolerant here, you can have more than one server, right? Instead of one server, now we have more than. You work as a cluster. So if something going down with this one, you still have the redundancy here. Okay, so that is a virtual machine you install based on the distribution tree, and you have the multiple on this one. So I think that's all for today. You have any question? Let me know. Any question? Huh? A lot of information.
No questions.
So we have a lot of information for today. So I hope you come back and look in the book. If you have any question, you can come back to me later. So basically for this here, many information. Have Spanish protocol. You have post security. You have hierarchical design, breaking down a 3 layer here. You have the software design network. You break it down and centralized network here. So every control information, every control plane is centralized by the single dedicated server here. You have storage area network. And virtual architecture here. You have the 2 types of the hypervisor. And you have the 3 types of the network connection. You can have the bridge mode, you can have the NAT mode, or you can have the host only mode here. And you have network function virtualization. That means you can virtual router or the switch. Okay. Cloud computing. You have cloud computing. You have the 3 types cloud infrastructure as a service. You have platform as a service and software as a service. And you also have information about the full program here, link aggregation. Okay, so let's see what is the homework here. So for this one, for this homework, you have the security switch port in the packet chaser here. So 7. Okay, so for this one, again, have the 2 network, right? You see, router here and break it down into branches. Each branch of the router is 1 network here. That's why you have 1 network here, 192.168.0, and you have another network here, 172.168. And for this one, incorporates the IP address here. Okay, now with the port security option. So for the port security, I mentioned it on the class already, right? The first step that if you know for sure you don't want to use it, to shut it down. Otherwise, you can configure the port security, and the port security you can configure based on the maximum MAC address, specific MAC address here. One thing about this one here, one thing about the interruption. One thing about the interruption here, I think that is missing 1 step here. Right. Somehow I want to do it here, right? So see, if you want to configure the port security or for the specific port, right, you have to go to the interface mode here. You have to go to the specific interface mode, right? And before you configure the port security here, before you work with the port security here, let me see if it's in check here or not. Let me check it again. Okay. Comment, where's the comment? Okay. So you go to the, and one more thing about when you work with the packages. So one more thing that you have to follow, right? What is it? Okay, you have to follow the instruction here, right? You see, you have to connect the PC2 here to the fast Ethernet 0F20. And you have to remember that you have to connect it to the correct port here. So that is only benefit when you work with the port security here. So remember that you have to connect it to the port F0/2 from the PC2, PC2 this one. PC2 this one. You make sure you have to connect to F0/20 for this one. Now configure the PC switch port here for security. I go enable. I think here is not, but that in the case when after you go to the interface for Ethernet F0/20 here, you need one more command here. You have the switch port mode access here. You have to put in the switch port mode access. Okay, so only after you configure the access mode, you are able to configure for the switch port for security. Now, let me show you how to do it. Okay, so think about this one, right? So I think I go to the short one. So first step, you have to go to the enable here, enable command. You go to the mode, and if you want to do with the configuration, you have to put the config terminal here. And I go to the config terminal here. And now, if you want to configure for specific port, F0/20 or F0/1 for this one here, right? So you have to go to the interface, F0/1. Now, if you want to configure the port security for this one, the first step, you have to switch port here. And you have the mode, you have to change the mode access port, otherwise it not work. For security, right? You see, it reject here. Reject because it's dynamic port, right? So the first step here, remember that you have to put switch port mode access here. So only after you configure the access mode, now you can put for the switch port for security here. So remember the command. Remember that when before the command here, before this command, before this one, you have to put the command here. Switch port. Exactly. Okay, so after that, you can configure for the switch port for security for the port. Yeah, you can see the switch port mode access. Okay, so that one is that I have you. Okay, here, see. Here, here's a switch port mode access here. Mode access and switch port for security. For this one, you see, for this one, right? It's set up the maximum here. Number one, that means for only one time you only learn it from the one incoming channel MAC address only. You can generate the fake MAC address and storm the switch here. And you have the switch port security violation himself. So we can have switch port for security. So we can have option here. So see, whenever you see what is option, right? You can put a question mark here. You can put a question mark here. So for this one, you can have violation here and a question mark here. So in the case of the violation, you have the three mode for the port here. You have three mode. You can have a protect, you can have a reject or the shutdown. And by the default here, by the default, it works with a shutdown. Shutdown, that means any violation, we mean shut down the port. You see in my simulation here, when I plug out the computer and plug in another computer, it's shut down here. By the default, it's a shutdown, but of course you can change it. You can change it to protect or reject here. So in the case of the protect, in the curve protect, if you have the violation coming in, right? If the violation packet coming, frame coming in, just drop it, and no shut the port here. Port still up. Just drop the incoming frame away. If you have a violation, right? So think about if you change from the PCA, now you connect it to PCB, it has violation here, right? But if you change it to protect here, the port is not, it's not shut down, it's still active here. But any traffic come from the PC here will be dropping. That is in the case protect. In the case recheck here, the port also, the packet, the frame is dropped, the port still active. And it sends the log, the log to the, you have the kind of the monitor here. You can see what is going on with the problem here. In the case you have the MTP here. Yeah, at MTP here. Now, remember the shutdown is by the default. Right? Whenever you have the violation, the port will be shut down. And by the default, if you don't change anything, any violation, the port will be shut down. And of course, you can configure the protect or reject here. Okay, so mark address table. Address table is maintained between the mapping between the MAC address and the port number here. Okay, I think that's all. That's all for the and you can go and work on that. If you have any challenge, let me know. You can send me the email or you can join my office hour anytime. My office hour every Tuesday and Thursday from 9 to 11 a.m.